Recording's on. Okay, so section 2.2 is functions. We're gonna do section 2.2. And then, because this is a math class, we'll follow up section 2.2 with 3.1. And then we'll go to 2.3, because that's just makes sense that way. Okay. So, guys, we're talking about relations. We're talking about functions. All functions are relations, right? What's the difference between a relation and a function?
Nothing. None.
What's a function? What makes a function a function? F of X is function notation. What makes a function a function? Okay, for every X value, there is one and only one Y value, right? That makes it a function. Okay, so this is what we're talking about today. Do what?
I think there'd be multiple Y's of the same number.
Now, easy stuff today. Many everyday phenomena involve two quantities that are related to each other by some rule or correspondence. Mathematical term for such a correspondent is a relation. In math, equations and formulas represent relations. An example of a relation is the formula for simple interest. I equals PRT. You're all familiar with that formula? Interest equals principal times rate times time. Okay. So if I want to know how much interest I'm going to earn, I on $1,000 for 1 year, 1,000 is my P, my time is 1. So the relationship between the interest earned is equal to 1,000 times the interest rate. And that'll tell you how much interest you earn on $1,000. How many variables are there? Okay, 2 variables. And those variables are I and R, which means there is a relationship, there is a relationship between I and R. Okay. The formula I equals 1,000 R is a special relationship, meaning that if you give me an R value, how many different I values can I give you? 1. If you give me an R value, I can give you an I value. That's it, just 1. Okay. A function from set A to B is a relation that assigns each element of X exactly 1 element of Y. That's what you said a while ago. A function for every X, there's only 1 Y. Okay. The domain, that's your input. The domain are your X's. The range, that's your output. That's your Y's. Anything new yet? So here's an example. I can have different times of day. And during the day, the temperature is going to change, correct? Now I have all kinds of numbers that the temperature could be. For example, at 1 p.m., the temperature is 9 degrees Celsius. Have you ever walked outside and the temperature be 2 different temperatures at the same time?
No.
Can you go outside and it's 30 and 70 degrees?
No. If it's
Not at the same time,
Well,
right?
well.
Now in
okay,
Texas, can you go outside and be 70 degrees and 20 minutes later to be 30 degrees?
Yes.
Absolutely.
But you can also go outside and it'll be like 30 degrees, but then, the wind, the weather app will be like, but the wind is making it feel like.
That's a different type of reading. One is the true temperature, another is something totally different.
I feel like if you stay in the shade, it's like 10 degrees cooler than if you stay in the sun.
I don't know what kind of shade you're sitting there. You got some good shade.
Okay, so here are a set of ordered pairs. This set of ordered pairs, let me ask you, is it a function?
Yes.
Because every X only has 1 Y. Okay, so characteristics of function. Number 1, each element in A must be matched with an element in B. Number 2, some elements in B may not be matched. Did you notice that on the temperature one while ago? All of the times were there, and every time was connected to some value, right? Some values weren't used, and that's okay. 2 or more elements in A may be matched with the same element in B. Did you see that one? Did you see 2 different times that went to the same temperature?
Yes.
Okay, 4 and 3, it was 15 degrees Celsius. That's okay. An element in A, which is the domain, cannot match 2 different elements in B. 4 common ways to look at a function. We can talk about it in words. In words, I can talk about a function and you can say, okay, that's a function, I get it. We can do it with numbers, listing ordered pairs. We can do it as a graph. I can show you a graph and say, hey, is this a function? And you could say yes or no. Or we could write the equation. Is it a function, yes or no? Okay. Here are 3 examples that may or may not be functions. The first example, letter A, says the input value X is the number of representatives from a state. And the output value Y is the number of senators. Is that a function?
No, because there's 2 and 2.
There's X to the
Because
same.
what are the X's repeats?
Yeah.
No, because of the.
We're trying to figure out A, not B.
We're doing A.
Oh.
We're only looking at A right now.
What are y'all talking about?
Yeah.
I literally thought.
It's just words in letter A. The input X is the number of representatives from any state. And the output value Y is the number of senators for that state. Is that a function?
Yes, because
Yes.
there's more representatives than senators.
Why not?
We don't know yet.
Well, yes, because the X is one.
Well, yeah, but B has X's and Y's too.
So we don't
Let's
know
jump
yet.
ahead to B. Is B a function?
No.
B is not a function because
X repeated.
X repeats with a different Y value. Notice how I said that. X repeats with a different Y value. So on B, an input value of 2 can have an output value of both 11 and 10, 2 different values. Okay, let's go back to A.
Yes.
If X is the number of representatives from a state and Y is the number of senators, is that a function?
Yeah.
Isn't there more representatives than senators in any state?
Okay,
We're missing, we're definitely being really dumb right now.
okay, so we're kind of struggling on the social studies side of this question.
Yes.
Okay, how does a state receive representatives? What determines the number of representatives a state receives?
The population.
Population. What determines the number of senators a state receives?
The resident.
Do what? There's only 2. Each state only has 2 senators. So what's the value of Y gonna be on this? 2. So if you have 6 representatives, you have output of
2.
2. If you have 8 representatives, the output is gonna be,
2.
listen carefully, if you have 6, you're gonna have,
2.
oh, I just said 6 twice.
But they have the same.
So
number.
no, it's
Okay.
not a function.
It is a function.
What? Well, that's the same.
It was 6 and 3.
I don't care if 6 and 6 are both there, the output value both times was 2. Every state has 2 senators. So yes, this is a function. For every X value, there is only one Y value that goes with it. Okay, so that's what I'm saying, be careful about the whole thing, well, X repeats. Let me talk about B again. The reason B is not a function is because the X value of 2 has 2 different Y values, one of 10 and one of 11. Okay. All right, is part C a function?
Yes, it passes
Yes.
the vertical line.
Passes the vertical line test. Great way to check for graphing. Here's the solution. So I'm not going to stay on this. If you want to snap it, you can. I'm moving on. Representing functions by sets of ordered pairs is common in discrete mathematics. This word discrete. I want to talk, undo that. I want to talk about this word discrete for just a moment, okay? If I was going to draw a graph, here's a graph right here. Okay, is this graph a function?
Yes.
Okay. Is this graph a function?
Yes.
Yes, it's not saying that.
It passes the vertical line test, right? It exists, all of a sudden it jumps, right?
Oh.
Right, okay, so they're both functions. Can you draw either one of those without picking your pencil? No one's talented enough to do that, right? Okay, I cannot draw those without picking my pencil up. It's discrete. There's 2 words that you see in math. One is discrete and the other is continuous. Continuous might look like this. Can you draw that without picking up your pencil? Yes. Okay.
How?
I just did it,
But you picked up your pencil.
putting the arrowheads on it, but that just indicated that it kept going.
What about a dotted line that's like,
Can you draw a dotted line without picking your pencil up?
no.
Okay. Okay.
But sometimes we.
Oh, I see.
If you fold the paper, theoretically, if you move the paper.
Theoretically, if you draw the line and then go back and erase little bits and
You
pieces.
picked it up.
You pick up the pencil to erase.
You have
Okay.
to pick it up to stop writing.
In algebra, it's more common to represent functions by equations or formulas involving two variables. For instance, y equals x squared. Y equals x squared is a function of x, right? Okay. The equation represents the variable as a function and as y is a function of x. X is independent, y is dependent. Okay, you can't tell me what the y value is unless you know what x is, right? Okay. The domain of a function is a set of all values taken by the independent variable x. The range, set of all variables taken by the dependent variable y. So remember that domain comes before range and x comes before y, right? So don't get your domain and your range back, that domain and range backwards. Are we struggling yet? Anybody swimming?
Yes.
Or do y'all want to go back to doing square roots and stuff?
No, I'm good.
We'll be back to the.
Actually, we do talk about square roots today a little bit.
No.
When using equations to represent a function, it's convenient to name the function for easy reference. So instead of saying y equals 3x minus 7, y equals 3x minus 7 doesn't mean a whole lot. But if I change that name, instead of using y, use f or g or something that makes sense. The example earlier was talking about interest depending on rate, correct? So if I took that basic equation, I equals PRT is what it was. And what they had it set to was I equals, nice, 1000 R, right? What does I stand for? Interest. So we didn't use Y here, but we, instead of writing it as I equals, I could actually change this to something else. I could actually change this to I of R equals 1000 R. And that's just saying, hey, this is a function of I that depends on R. It's saying the exact same thing, but I'm being very explicit here saying the value of I depends on R. Once you tell me an R value, I can tell you the I that goes with it. And that's what this is talking about, changing everything. So the input is X, the output is f of X, the output is Y, right? The equation f of X equals 1 minus x squared. The symbol f of x is read as the value of f at x, or simply f of x. The symbol f of x corresponds to the y value. So y is equal to f of x. Keep in mind, f is the name of the function. F of x is the value of the function. You'll see the difference there. F is the name of the function. F of x is the value of the function. F of x is that y value, okay? F of x is the value.
Okay.
Okay, f is the name, f of x is the value. Okay, so f of x equals 3 minus 2x, has function values denoted by f of -1, f of 0, f of 2. What is that saying? What does f of -1 mean? What is the value of the function at -1? What is the value of the function when x is 0, right? So to find that out, we would plug the numbers in, right?
Yep.
Okay, so next slide, we're gonna plug the numbers in. So here we go, we have plugged in the 3 values. When you plugged in a -1, we got an output of 5, plugged in 0, get an output of 3, 2, get an output of -1. What are you gonna say?
Okay.
So it's convenient to use f, it's convenient to use x, and we fall into a rut, and all we ever do is f of x. Okay, you don't have to. I just showed you I of R. Okay, here's f of t. This might be a function of time. So t would make more sense of using than x. G of s, I don't know, the number of gallons used based on the number of,
Seconds.
sure, sounds good. Your car burns a gallon of gas every second. Good luck.
Could be making last month.
Gas station would be.
Oh, yeah.
Okay, this slide right here just says, you know what, I don't care what variable you use. Okay, f of, this is like the second grade level, you know. F of box equals box squared minus 4 box, whatever. I don't care what variable you put in there, it doesn't really matter. But they all have to be the same, right?
Yes.
Do they know, as long as you know what they mean.
You remember piecewise functions? Okay, so we didn't like piecewise functions. We're gonna make a little visit to them real quick.
No.
Okay, so I have a piecewise function defined as f of x is equal to x squared plus 1 when x is less than 0. F of x is equal to x minus 1 when x is greater than or equal to 0. The question is, what is f when the x value is -1, 0, and 1?
What?
Okay, so when x is -1, which piece of that function has a domain that includes -1?
The first one.
Okay, -1 is less than 0, true statement. So to find out the value of this function when x is -1, I will plug -1 into the first half. -1 squared is,
One.
1 plus 1 is,
Two.
okay, there you go.
I feel like that was really easy compared to the problems they're gonna give us.
What about when x is 0?
Then it's gotta be the second.
Does it have to be?
Yes, it's equal to.
Because it specifically says x is equal to 0. Okay? So I plug 0 into the second function, 0 minus 1,
-1.
okay? And what about the 1?
It's gotta go in the second.
Because
It's greater than 0.
1 is greater than or equal to 0, therefore plug the 1 into this one, and when we get
Zero.
0. Okay, I'm gonna change gears for just a second. I'm gonna write a different piecewise function.
Why'd you just change it to G?
Do you just plug 0 in,
It's giving us a value.
but 0 wouldn't
Right, but zero's
any
less
of
than
there?
zero. Did you say zero? No, it don't work.
Oh, wait, no.
Yeah.
It'd be,
You can't.
Solution,
It can be
undefined.
zero.
Why not?
X is less than zero, X is greater than zero.
but zero can't be less than zero. Right?
Okay. So a piecewise function has two things going on. It's got the pieces, and it also has the defined domain. So for f of x, what is my domain?
Anywhere.
-infinity to positive infinity. Every number is included. The domain of f of x is all real numbers, correct? Is that the domain of g?
No, it's everything but 0.
Okay. So the domain of this is from -infinity to 0 with parentheses, right? Because 0 is not included. Union, parentheses, 0 to infinity. If I ask for what is g of 0, the answer is undefined or doesn't exist. Why? Because 0 is not part of the domain. Okay? Undefined.
Why can't we do stuff like this all year?
We do, it's just at different levels.
Why can't we just stay at this level?
Can we not include that?
Everything we do.
Everything we do.
Radicals could stay out.
Okay, and we already did all of this. Next slide. All right. Bless you.
Thank you.
When given a function, without me looking at this function, there's a function behind it, okay? Before I look at it, I'm going to take the approach of this function as the domain is all real numbers, okay? Then I look at the function and things might change. What do you see going on in this function? What's happening?
Being divided
We're dividing. Where's the variable?
on the bottom.
On the bottom. What can you not divide by?
Zero.
You can't divide by 0, okay? This is called an implied domain. The domain is implied. I don't have to tell you what the domain is, okay? It's meant, the words that I'm using are up here. It's an implied domain. So by looking at it, we can have to say, okay, yeah, I can't divide by 0. And they go on and give you the answer and it says that the implied domain is all real x other than plus or minus 2, but where'd that come from?
Can't equal 0.
Okay, that's exactly what they did. They said, okay, well, I've got the denominator, and because I have a denominator, I know that I can't divide by 0, which means my denominator, x squared minus 4, can't be 0. Now, we're going to work this like it says equals 0, okay? Can you factor x squared minus 4? Difference of 2 squares, it factors into?
X
Equals
and,
2.
X
minus
plus 2 times x minus 2. Which means x plus 2 cannot equal 0, or x minus 2 cannot equal 0. And when you solve both of those, this would give you x can't be negative 2. And this one would get you x can't be positive 2. Okay, so those two x values, plus or minus 2, make the denominator 0. Can't divide by 0, therefore the domain of this does not include plus or minus 2. They're excluded from the domain. Questions on that? Okay, so the first big issue we're gonna see is dividing by 0. If you see that happening, we gotta get rid of it.
So if we're dividing by 0, then it's something in black.
That is implied, yeah.
Okay.
Okay. All right. The second problem we have is radicals. Okay, we're not gonna go imaginary though. Let's stay in the real world.
Why?
Are we
Okay.
exponentially?
Let's stay in the real world for a while now. What can you not take the square root of? You cannot take the square root of a negative number. Okay? So to find the implied domain of a radical, you take the radicand. What's the radicand? The stuff on the inside, and you say, okay, I'm taking the square root here, and there's no math to do on this one. I'm taking the square root of something, so that something must be not negative, which would mean greater than or equal to, can't say positive because of 0. Okay, so the implied domain of f of x equals the square root of x is greater than or equal to 0. Or bracket 0, comma, infinity, parenthesis. Okay, so the implied domain is the interval notation, 0 to infinity with a bracket on the 0 because it can equal 0, but I don't know where infinity is. All right,
Does that mean? We still have to solve it to get the domain, right, though?
we've got the domain, sir.
But it's implied.
Correct.
Which means you're-
I mean, you
Yes.
might have to do some work to figure out what that domain is, yes. And here in a minute, we're gonna actually combine dividing and radicals.
No.
Okay, and it's not that bad.
But you say it's the way we open our homework.
Okay, moving on.
7 different numbers and 3 different variables, it's like.
Letter A,
It's simple.
what's the domain? Letter A, what is the domain? -3, -1, 0, 2, and 4, right? That's it.
It was definitely a trick question. He was trying to see if we were gonna say something like the implied or whatever.
Okay. Do not tell me that the domain of that is any number from -3 to 4. Don't give me an interval -3 to 4 and say that's the domain, because it's not. The interval -3 to 4 would include such numbers as
Negative.
1 or 1/2, or, see what I'm saying?
4, 3.
-2, 3, right? Those aren't part of the domain. Okay, this happens to be what kind of a function? There was two kinds. One started with a D, one started with a C.
Discrete.
This one's discrete, so this is just a bunch of points.
Oh.
Okay. B, what is the domain?
Any number but 0.
It can be 0.
Any number but plus or minus 5.
Anything but -5.
Anything but -5.
Wait, what, why?
Why can't it be
Okay.
+5 then?
Because 5 plus 5 is 10.
What?
Okay, so what can you not divide by?
0.
Because you can't divide by 0, I'm gonna say, okay, here's my function. Before I do anything, my domain is all real. But I can't divide by 0. So I know that my denominator is x plus 5. X plus 5 can't be 0. Because if x plus 5 is 0, now I'm dividing by 0.
Oh, because you only have one thing to.
I still feel like you're doing it very complicated.
So x can't be -5. The denominator can't be 0,
I see it.
okay?
Just -5 plus 5 equals 0.
Correct, that's what I got. Okay. So when you're dividing, if the variable's in the denominator, you take the whole denominator, whatever it is, you take the whole denominator and say it can't equal 0 and solve it. Okay, C, the volume of a sphere, V equals 4/3 pi r cubed. What's the domain?
That's wrong, guy.
What?
V equals 4/3 pi r cubed.
How do you even calculate that?
Plug numbers in.
R? Yeah, but
Okay.
you don't know the radius.
R's correct. R, so R is the radius. Y'all are right. R is the radius. Tell me what R has to be.
I'm 0.
Okay, because what would happen if R was 0?
We wouldn't have a circle.
You don't have a sphere. Okay, what else can R not be? Yeah, can you have a sphere with a negative radius? We don't measure distance in negative, right? That said, what's the domain?
All point. It's the
0 to infinity.
0, the radius is.
Greater than 0?
I thought it couldn't be 0.
We can't.
There's no equal sign. Okay. So a spherical grain of sand has a radius, right? Yes. Very, very small.
Give up on that.
Okay, part D. What do we have going on in part D?
Miraculous.
A radical. Taking the square root of something. That something has to be not negative. I don't want to say positive because of 0, right? So because I have a radical, to calculate the domain, I'm going to state that 4 minus 3x must be, that's nice looking x, kind of did. What can you tell me about the value of 4 minus 3x? It must be
Non-negative.
greater than or
Equal to.
0, equal to 0, because I can take the square root of 0, and hopefully you can too. Let's solve this.
But you can't do that more, because you could put in 2 for x, it would still be negative.
Do what?
You have to add one more, because you put in the 2 for x, it'd be 4 minus 6, you still have a negative.
I need to know what x is. We've got to solve this. This is gonna tell me what it is.
Just subtract 4. and
Okay,
divide
subtract
by
4 from both sides.
Yes.
Perfect. Negative 3x is greater than or equal to negative 4. Next step,
Divide by -3.
which means what?
You
X
supposed
is
to sign.
less.
Flip the sign. Right?
Yes.
Yeah.
So dividing everything by -3 gives me x is less than or equal to
4/3.
4/3.
Okay.
Okay? So that would be from 0 to, I'm sorry. negative infinity to 4/3 of the bracket.
Yes.
So always pay attention, how do they want the answer given? Okay, if they want an interval notation, make sure it's an interval notation. They want it written this way, right, whatever they ask for. Okay, next slide has all the answers. Oh, some of them. Part A, we got the domain right. Part B, we said it can't be -5. Part C, we determined that the radius had to be greater than 0. Moving on. Part D, we said that x has to be less than or equal to 0. So if we run an interval notation, we have negative infinity to 4/3 bracket. This is more discussion about the fact that we can't have a negative radius, okay, nor can we have a 0 radius because it makes no sense. Yes.
For like doing the homework
Huh?
side of things, the ones that say you like it can't equal something, do you still put the equal sign? Because on the board it still does.
It says, accept.
Yeah, it said except. It was the way it was worded.
Yes.
So you would put an
Okay.
equal sign.
Yeah, that's the same thing.
Just imagine, this is so much easier than pre-cal, like it only gets worse.
It's a good thing I'm not taking pre-cal.
Okay, the difference quotient. The difference quotient says that f of x plus h minus f of x divided by h. This is actually ties into calculus. This comes into play when you're trying to determine the derivative of a function. Means nothing to y'all right now, but in calculus, this is huge. Notice it says h can't be 0. How come?
Because it would be divided
Can't
by.
divide by 0. Okay, so make sure you know the difference quotient. All we're doing, we're gonna take the f function, whatever it is, we're about to do one. We're gonna take the f function, and in place of x, we're actually gonna write x plus h. And then we're going to subtract the original function from that. And then we're gonna divide by h, and it's when we divide by h, magic happens, and the answer has no division in it. Okay, if that h, when you get done with the difference quotient, if this h in the bottom does not cancel, you goofed. Because the whole purpose of this is to cancel this h. All right.
What is the purpose of this equation? What is this equation 5?
Can you find the slope of a line? The slope of the line is y2 minus y1 over x2 minus x1. It's division, right?
Right.
To find the slope of a line, you have to have 2 points.
Right.
If I had a curve like this, here's a point right here. That's 1 point. There is a line that goes through that point called the tangent line. The tangent only touches a curve 1 time. How would you find the slope of a line that only has 1 point? If you only had 1 point, you would have x minus x. Y minus y over x minus x, which gives you 0 over 0. You can't do this. So since we can't do this, calculus brings in this equation that says, okay, what if h is a big number? So I've got a point here and a point here. I could get that slope, right? And as that distance h gets closer and closer and closer to 0, that would give us the tangent line. So I mean, it's deep, it's deep.
Math feels like a bunch of people
Okay.
realized they were wrong, but instead of admitting they were wrong, decided to add more rules to make themselves right.
Yes, that's exactly what Matt
It's a
said.
very boring.
Okay, summary of function terminology. If we look at function notation, y equals f of x, f is the name of the function, y is the dependent variable, x is the independent variable, f of x is the value of the function of at x. I don't know.
Would you mind repeating? I
Okay.
don't remember if I-
And moving on to the next one.
Sorry.
Difference quotients. The domain of a function is a set of all values of the independent variable for which the function is defined. If x is in the domain, then f is said to be defined at x. The range is all the output values. The implied domain can't divide by 0, can't take the square root of a negative number. So the implied domain, we don't have to state where the problem exists, you got to figure it out. Here is the problem, we're going to calculate the difference quotient. And I'm not going to go and uncover what they've got, I'm actually going to work this one out for you. Okay. So to find the difference quotient, I'm going to take my function, x squared minus 4x plus 7. I'm going to plug x plus h into it. Then I'm going to subtract this function, dividing the whole thing by h. So let's look at what f of x plus h is. So I'm going to take the value x plus h and plug it in for x. So this x here becomes x plus h squared minus 4 times
X plus eight.
x plus h plus 7. Here's where you're going to mess it up. The easy part. Because you're going to put this minus sign here, and then you're going to write this function down. That's wrong. We are subtracting the entire function, which means we're subtracting the function, put in parentheses. Okay, so I'm subtracting x squared minus 4x plus 7. Can you see that by putting in parentheses, that negative sign is going to be distributed? Okay, divided by h.
It really bothers me, there's only 2 numbers.
Okay, at least it's not, there's no
Okay.
radicals.
Let's do x plus h squared. I'm not going to write it down as x plus h and x plus h. Let's just do this real quick. First times first.
X squared,
Okay. Outside times outside,
XH,
inside times inside.
XH.
So I have an xh and another xh gives me
2x plus 2. Plus h squared.
plus h squared, last times last. Next, distribute this. So minus
Negative
4x,
4x minus 4h.
okay,
Plus
Plus 7.
okay,
Minus
Minus
x squared plus 4x minus 7.
all over,
H.
okay.
That
The
is
big equation
a
for no
long
reason.
equation.
Here's something that's interesting. Every term in the top that does not have an h actually cancels.
How?
What is x squared minus x squared?
0.
Gone. What is negative 4x plus 4x?
Nothing.
Gone. What is 7 minus 7?
Nothing.
They're all gone. What's left?
2xh plus h squared minus 4h.
What do all those have in common?
H.
They all have h's. Okay,
So we get left with
so what I'm going to do is I'm going to take those 3 terms that are left. I'm going to take out an h. Okay, take an h out of this, I'm left with.
2x.
Take an h out of this, I'm left with
H.
plus h
minus 4.
minus 4. And all of this is divided by,
H.
which means,
They cancel.
so the final answer,
2x plus h minus 4.
2x plus h minus 4.
That isn't as hard as I thought it would be.
Huh?
Easier than I expected.
He said that there gets to be radicals, so didn't he?
We've done some radicals today.
Isn't that bad?